Okay, for what we have in problem number 4, suppose Sam places $2,000 in an account that pays 7% interest compounded each year. Assume that no withdrawals are made from the account. Follow the instructions below. Do not do any rounding. And it says to find, first of all, the amount in the account at the end of 1 year. Okay, so we have annual compounding of interest, and we have just taking what we have in the formula. We have A is equal to P times the quantity of 1 plus R raised to the T degree. And again, P represents the amount that is put in, which we will have at $2,000. And we have for R, that is the rate of interest. So we have at 7%. And in the formula, we're going to record the decimal equivalent without the percent. So 7% would translate to 0.07. And so for the amount after 1 year, and using this formula, so you have 2,000 times the quantity of 1 plus 0.07, and we have to the t's, and t is only 1, so we have 2,000 times 1.07, and for what is going to occur in this case is that the future value after 1 year, that is going to be at $2,140. Now, for what the future value is going to be after 2 years, okay, so you have the same formula. So you have 2,000. Again, we have 1 plus R, we have 1 plus 0.07, and to the T we have to the second, and here we have 2,000 times 1.07 to the second, and for 1.07, okay, raised to the second, so you have 1.1449, and multiply by 2,000, so we have at 2289.80. Okay, and to the nearest dollar, okay, that would be about $2,290. Okay, so we have just checking what we have for the outputs. Okay, so you have 2140, and after 2 years, okay, it says do not do any rounding. Okay, so we have 2289.80. And checking the results in this case. And the answer is correct. Okay, for number 5, a principal of $2,700 is invested at 4.75% interest compounded annually. And the question posed is, how much would the investment be worth after 9 years? And for what we have in this case, all right, so we still had the same formula that was used in number 4, so we're still looking at annual compounding. Okay, so you have A is equal to P times the quantity of 1 plus R raised to the T degree. Now we have with the principal what is put in. Okay, we have at $2,700, and for the rate we have 4.75%, and converting to a non-percent decimal value we have at 0.0475, and we're looking at the future value after 9 years. So putting in the quantities, okay, so we have 2,700 times what's going to be 1 plus 0.0475, and to the T power we have to the 9th power. So you have 2,700 times 1.0475 to the 9th power. So we have with this exponential base, so you have 1.0475 taken to the 9th power. So you have a little bit over 1.5, so you have 1.5184, and just keeping the decimals, and then multiplying by 2,700. So you have about $4,099.68. Okay, and so we have, so you have here. Okay, so rounding to the nearest dollar. So this will be about $4,100. And just testing what we have in the result. As I enter, and we have upon awaiting the result. And the answer is correct. Okay, for what we have in number 6, an initial amount of $3,500 is invested in an account at an interest rate of 8% per year, compounded continuously. Assuming that no withdrawals are made, find the amount in the account after 4 years. And it says do not round any intermediate computations and round your answer to the nearest cent. Okay, so we have with continuous compounding, we have A is equal to P times E raised to the R times T degree. So we have what is put in, we have 3,500, and the rate of interest we have 8%, and as a non-percent decimal again, this will translate out to 0.08, and the time span is going to be 4 years. So in looking at the future value, so you have P, again we have it 3,500, and we have times E, and this will be raised to the R times T degree. So R we have at 0.08, and T we have at 4. So we are looking at 3,500 times E raised to the 0.32 degree. And again, we have with E to the 0.32 degree. And so we have here with E to the, so E to the 0.32 degree, we have right at 1.377, and keeping all the decimals and multiplying by 3,500. So we are looking at $4,819.95. So in looking at what we have now, so we have 4819.95 and checking, and the result is correct.